Welcome to Freshwater Distribution and Behavior, an 8th grade EOG review. I am Miss Crum from Apple Valley Middle School. We are the blue planet. 70% of Earth is covered in water. You can see that when you look at any picture of us from space, and everyone likes to stay at the beach. So of course, where you look is this water, 97% of Earth's total water is in the ocean. This is important because that means it's saline, meaning it's useless to a lot of organisms that require fresh water, including us. So that leaves just a mere 3% of the world's total water is fresh water in that hydrosphere. So that means water in the atmosphere, water in your body, water in lakes, rivers, and streams, fresh groundwater, ice caps, glaciers. All of that is just 3% of the total water on the planet. Now, of that 3%, 68% of that, meaning 2/3 of that 3%, is ice caps and glaciers. So it's inaccessible. We can't use it. There is not a way that is feasible economically or ecologically to take a ship up to the Arctic and lob off chunks of glacial ice and melt it to be fresh water for drinking water for us. In fact, water, even though, of course, we all know the hydrologic cycle, that cycle of evaporation, condensation, precipitation, evapotranspiration, etc., even though that is continuous and cycles the water indefinitely, fresh water is actually relatively finite because when it rains, it continues, of course, to rain on that 70% of the earth that is covered in salt water. That fresh water, that fresh rainwater immediately becomes saline when mixed with that salt water. But also because we as human beings tend to like to pollute things that we use and rely on. So we have a lot of industrial waste that we just put right in our rivers and streams. We put our sewage in our rivers and streams. We take a lot of groundwater that takes a long time to infiltrate down the soil and build up. We're using that a lot more quickly than it can be recharged. So this is important that we are actually leaving to ourselves only 1% of Earth's total water is accessible, usable, fresh water. In fact, there are people who study policies and world wars, and there are many people who believe that our future conflicts are going to be water-based conflicts. And those are going to be the most important globally. So this is something we really need to be thinking about. Where do we get our fresh water? We get our fresh water, our drinking water that comes out of the tap. It doesn't just come from some magic place that holds all the water. It comes from either an aquifer or some sort of groundwater or a river or reservoir. And those reservoirs, it just means a holding place for water. And that can be a natural reservoir like a natural lake, or it can be a man-made lake behind a dam. So it's important for us to understand, as we study water, the behavior of water. Water flows down, and that's going to be due to gravity, whether it's downhill or vertically down, infiltrating through the surface. And which of those it does depends on whether that surface is permeable or impermeable. Permeable surfaces are going to allow water to pass through. So in nature, a permeable surface is going to be like this soil here. You put some water on that, if I wait long enough, it'll start to seep through. So on this side, you can see there's finding those pores relatively quickly, and it's seeping right on down. That infiltration is that process of moving between particles till it reaches a part that's impermeable. So here in my small demonstration, the impermeable surface is the plastic at the bottom of this cup. In nature, of course, there's not going to be a big plastic container holding it. There's going to be instead a rock. And then it's impermeable. Because when water flows on this rock, it just goes right off. It does not seep in at all. It goes right around the edges. But if this was a big, long piece of rock at the bottom, a bedrock, it's going to hold up water for very big areas. It's going to act like a big shelf, a big sink, and hold that water. So pores are spaces in between rock and soil particles that allows water to pass through. Pores exist in permeable surfaces, such as the sediment, and do not exist in impermeable surfaces, such as these rocks or concrete layers. Groundwater is an area that is saturated zone. That's an area that's totally filled with water. It can take no more. So remember from our sponge experiment earlier in the year, we talked about how we set the sponge down, it got very, very wet, and when I picked it up, it was dripping with water, and that was fully saturated. But then we squeezed that out, and it was unsaturated. It was still moist, it wasn't a fully dry sponge anymore, but it was unsaturated. Now, so if we look at this, our soil sample, we allow that water to pass through, and when it starts to build up, it's collecting here at the bottom. It's collecting right at where the impermeable surface meets the permeable surface. And as it builds up, when that soil can hold no more water, when there's no more space to be filled, that area will be saturated. This other area above will be unsaturated because it can still hold more water. It's not completely full. And where those two meet, where that saturated and the unsaturated zone meet, you can think of that as a tabletop or the water table. So infiltration, of course, is the process by which the water enters the soil, and the aquifer is the rock layer that stores and allows for that flow of groundwater. So you might see diagrams on the EOG that look something like this. I'm like, how deep should the well be to provide for a family? We want to see that red line. It goes down into the saturated zone where there's lots of water there, but it doesn't stop in the unsaturated zone. In the unsaturated zone, you get too much sediment and rock and not enough water. But if you go all the way down to the bottom of the saturated zone, again, you're getting muck and things that are built up here on your impermeable surface. So you also don't want to be right at the water table where the two meet, because just like if I were to put my drinking straw in a cup and start drinking right at the very surface of my water, as soon as I take a sip, I can't reach any more water. My straw's now too short. So you want to make sure that straw is down deep in the middle of your water in your saturated zone, so you have plenty of time to keep sipping. So how do we protect our groundwater from runoff? This is a concern because water is the universal solvent. It likes to grab friends anywhere it goes and take them along for the ride, and often those friends are contaminants. Thinking about when you see those water rivers, when it's rained really hard and really fast for a short period of time, and you're driving down the road and you see that water going down the side of the street. That is not clean, pristine water. That's carrying litter, it's carrying oil and grease and contaminants from parking lots. So fast-moving water is not our friend, right? If I pour water on here very, very quickly, right, it's going to just build up on the top. That soil is choking on that water. And just like you may remember earlier in the year, right, if I said, you have 10 minutes to drink roughly this amount of water. You could do that if you wanted to, if you're motivated. That'd be not a big problem. If I said, you have 2 seconds to drink this water, and I pour it in your mouth, you're going to be choking because your body cannot absorb it as quick as I am giving it to you, even though you have spaces for that water to flow. Just like this soil is choking on this water. So this water is not going to infiltrate. Some will, but the rest of it, if it wasn't confined by the restraints of this cup, it would just flow right off. It would run off. And so if water comes down too fast and too hard, you're going to create that runoff. But slow water increases infiltration. So the key here, and of course sediment and soil, cleans our water. So we want water to infiltrate into the ground because that cleans out anything that has been dissolved into the water in the meantime. How do you do that? You slow that water down. So increase infiltration, reduce runoff. You're going to do that by planting things like rain gardens, trees, shrubs, grasses, and then of course wetlands are like a natural sponge. They are those collectors of water. They slow that water down and clean it really well. They're actually wonderful filters of water. However, we do like to develop them and drain them as a society because they typically tend to be near the shore, which is high value property. That's something you should be thinking about. And are those values that we want to instill? So here we're starting to see that my cup of soil is starting to be saturated. And so it might not absorb all this water. This might not actually infiltrate because too much water was in this area. So again, the keys here are that only 1% of the Earth's global water is reusable fresh water. That water is threatened by human overconsumption and also contamination. And the ways that we can reduce our impact, our negative impacts on our drinking water, in which we, of course, rely, is to increase infiltration and reduce runoff. And you do that by slowing the flow of water down. This has been Freshwater Distribution and Behavior, an 8th grade EOG review. Thank you.